Hello everyone, I am Namita from CSCB. Today we are going to discuss about system call. So the contents involved in it are introduction, types of system call, process control, file management, device management, information maintenance, communication. So let's see one by one. First, introduction to system call. So system call provide an interface between a program and the operating system. They allow user mode applications to request services from the OS, such as accessing files, managing memory, or controlling devices. So, for example, when a program needs to read a file, it makes a system call to ask the OS for permission. So, it is also available as assembly language instructions. So, the system call acts as an interface between the OS and the process. So, next, structure of system call. So it allows program to access hardware resources like CPU, memory and input or output devices. So system call acts as a resource provider for the programs. So it performs file operations such as reading, writing and closing files. It allocate and also deallocate the system resources. So first of all, the CPU and main memory are interconnected together and the input to enter into the CPU is processed and output is given out. In between, the CPU and main memory are interprocessed together and exchanges the information, and the process which is done in CPU is stored in the main memory and it's given to CPU when it's required. So this like allocation and deallocation of memory. Next, modes of system call. It consists of two modes, kernel mode and user mode. So first of all, in user mode we are executing the process in isolation from the OS. It does not have any connection with the OS. It does not also have the direct access of information in the OS. So let's see each and every modes. So first, kernel mode. Kernel mode is a core component of OS. It's also known as the heart of OS. Without kernel mode, we cannot perform any process in system call. So in kernel mode, it has full access to hardware resources and it can be directly access the memories and resources present in the OS. So it's said as a privileged mode because it has the extra benefit of accessing the memory directly and resource allocation can be done by itself. It can also execute critical system tasks alone. So inside the kernel it is most privileged and while moving out of the device it's becoming the least privileged. So it is clearly shown in the figure given. Let's see that and first we are having the kernel inside and it is having the most privilege and afterwards it's moving to the application stage, it becomes less privileged. Next, user mode. User mode it runs the application in isolation from an OS. If a program crashes, it does not affect the entire system or application. It also cannot directly access the hardware or critical system resources. It always relies on the OS service to perform the task and it does not have any privilege as in kernel mode. So user mode is mainly used if continuously we are assigning the task, the kernel mode cannot perform it, it can move to halt state at some stage. To overcome that halt stage, we are using the user mode. Programs in user mode must use system call to request service from the OS. As it cannot directly access the OS, so the system call have to request the service from OS. Next, the comparison is given between user mode and kernel mode. So in user mode, it is low privileged and kernel mode is higher privileged. And user mode cannot access to hardware and kernel mode can be access to hardware directly at any time. And memory is limited in user mode. It has a full access for memory in kernel mode. Execution environment is user level application for user mode and OS and kernel components are involved in kernel mode. So that if user level application is given, it's less privileged as it moves out of the kernel mode. But in case of kernel mode, it has more privilege as it's the core component of the OS. So error isolation. Process in user mode are isolated and kernel manages the process isolation. and it is run user applications in user mode. The kernel mode manages the system resources and hardware. An application crashes do not crash the OS in user mode. If kernel issues in kernel mode, if there is any issues, it crashes the entire OS system. So it is somewhat having the disappointment or disadvantages in this system. And next, requirements of system call. System calls are mainly needed for file operation, process management, network communication, and hardware access. So file operations are creating, deleting, reading, writing, etc. whatever we do using the files, and process management is nothing but creating and managing the running task. Network communication means sending or receiving the data over the internet. So it is nothing but sharing the information through the communication medium, and using the internet is known as network communication. And hardware access means printers, storage device, etc. or hardware which is accessed for any resource sharing, etc. So creation and management of new process is also done in system call. Access to hardware requires a system call. So without system call, we cannot directly access the hardware devices. And types of system call, we have majorly 5 types. They are process control, file management, device management, information maintenance, and communication. So first let us see process control. It handles creating, running, and termination of process. The OS maintains a process control block to track each process. The OS stores the process control block in a process table. It is stored in the table format. It has the many conditions like new, ready, running, waiting, or termination of process. So process control block contain various pointers, process state, process number, register, memory limit, etc. which can be seen there. So the process control block stores mainly the process state and CPU registers and memory details. So all are comes under the process control block. Next we are going to see file management. It manages the file operations and it's used for file manipulation like creating, inserting, deleting, reading, writing, etc. All the file operations can be performed in file management system. It also stores the relevant information, and the operations can be performed are open, write, read, close, mkdir. So open is used for opens the existing file or new file, and write means the writing the values into a file, and reading from a file and closes a file. Mkdir is used for creating the new file. Next, file management in system call. It performs various file management operations. Files are organized in a directory structure. Each file contains some record of data in it. So we have root file and subdirectory file. So a root file holds the values given in the subdirectory file, which is entirely stored into the computer system under the OS. So OS ensures the proper storage and retrieval of files. So OS only decides where the file to be stored and how it's to be organized and accessed. So organizing the file helps us to accessing to be very easy. So if we are keeping in organized manner or giving the separate place for organizing the files, it also reduces the memory congestion, and also accessing makes the easy, so it reduces the time. Next, device management. It controls how hardware devices interact with the OS. Input or output device management. It handles communication with keyboard, printer, etc. And device driver management. It manages software that controls the hardware. And then it performs resource allocation. It assigns devices based on the priority, and data transfer is also performed in this. Like it moves the data between devices and the system. So various OS can also involve in the data transfer between two systems. Next, information maintenance. Information maintenance is a system call that manages information between user, program, and OS. Managing the system informations like time, date, and memory usage, and transferring the data between user and the OS, and also handling many error messages and logs given in that. Like we can see some of the system calls under information maintenance, like get time or the set time, logically attach or detach devices, information maintenance, get system date and system date, get process file of device attribute and set process file or device attribute. Next, working of information maintenance. A user program makes a system call to request information. So when the user requires some program, the system call makes a request to information. So OS switches from user mode to kernel mode. After switching, the OS retrieves and returns the requested data to the user program. So when a system call makes a request, it switches the mode from user to kernel, and then it retrieves the data requested by the user to the program. Next, at last, we are seeing about communication. So communication is nothing but making the two systems or two OS to communicate between them along with the use of networks. It enables the data exchange between the various processes. So user inter-process communication, like pipes. Pipes is a unidirectional way for process to share the data, and message queues. It's a system for sending and receiving the messages. So shared memory is used. It is a memory space which shared by the multiple process. So it consists of two communications, inter-process communication and network communication. So in inter-process communication, the application sends a message to an OS, which then sends it to an IPC mechanism. So first the OS receives the application. After that it moves to the inter-process communication mechanism. It handles the message and sends a response back to the application. So the chart will be application to IPC mechanism, and IPC mechanism sends back the result to application. Next, network communication. Network communication means system calls allows programs to send and receive data over a network. So with the help of network, we are sharing the data or resources. It is known as network communication. So thank you.